Lesson 5.6. This will be our last lesson for this chapter, and this is on the law of cosines. So we've been talking a lot about solving triangles, especially with your last lesson where you were using the law of sines, but we were limited as to what we could do and what kinds of triangles we could solve with just the law of sines. So when you are trying to solve an oblique triangle, and an oblique triangle simply means that it's not a right triangle. So there's no right angle in it so that we can use Pythagorean theorem or SOHCAHTOA or anything like that. So if we're trying to solve an oblique triangle, there's basically 4 different cases that you could have and be asked to solve. And in all of these cases, you're going to need at least one side to be able to solve it, and then 2 of any other parts. And so in our first 2 cases, with the 2 angles in any side, or the 2 sides with an angle opposite one of them, those 2 worked pretty well with our law of sines, and that's what you were doing last lesson. But law of sines didn't really work with these other 2 cases, when we only know all 3 sides, or when we know 2 sides and their included angle. So these are the cases that we need a new approach for, and that new approach is called the law of cosines. Now when you look at this formula for the law of cosines, what you need to understand is there's really just one formula, but they're showing it to you in all of the 3 different configurations. It all depends on what your angle is here in the cosine, because that's going to determine which side gets squared out here. Okay, so if we're taking cosine of angle A here, then that means side A is what's going to get squared out here. If we're taking the cosine of angle B here, then it's side B that's going to get squared out here. And if it's cosine of angle C here, then it's side C that's going to be squared there. And then whichever side is not out in front, those 2 sides get used in the rest of the formula. All right, so let's see how this works. So we're being asked here to solve triangle ABC with a side A equal to 12, a side C equal to 16, and an angle B equal to 38 degrees. Now, as I think I've been telling you all along, I hope that you're picking this up. If you don't have a picture for this, the first thing I would really recommend you do is draw yourself a quick diagram. It doesn't have to be beautiful. It doesn't even have to be to scale. But just draw a diagram and label the parts that you know. And then make yourself this little table where you put your angle measures A, B, C and your side measures A, B, and C, just so that you can keep things organized and you know when you have all of the pieces found and you have your triangle solved. All right, so we'll start filling in the triangle with the pieces that we know. We know side A is supposed to be a 12. We know side C is supposed to be a 16. And we know angle B is 38 degrees. Now, when you look at this, you realize that angle B is here, side B is here, and we don't know what that is. So this is not a good case to be using law of sines on. So that's where we're going to use our law of cosines. So because the one angle we do know is angle B, that's the angle we're going to want to put in the cosine. So side B is the one that's going to go out in front when we set this up. So B squared will equal one of the sides that we do know squared, so A squared will be 12 squared, plus the other side that we know, which in this case is side C, that's going to be 16 squared. and then minus 2 times the A of 12 times the C of 16 times the cosine of my angle B, 38 degrees. Now, in a case like this is pretty nice because what we're trying to find is already out here on the left side. So this is just a matter of plugging it into your calculator, taking your 12 squared plus your 16 squared, and then subtracting 2 times 12 times 16 times the cosine of 38. That will get you a b squared that is equal to approximately 97.4. But remember, this is b squared, so we need to go one more step and take the square root of both sides. Let's do that again. So that we end up with about 9.9 for side B. All right, so 9.9 for side B. Now, because I've just been able to find side B, that means I can now also find the other pieces because now law of sines fits. So now I have angle B across from side B, so I can set up the ratio that the sine of 38 over the side 9.9 will have to be equal to the sine of whatever angle A is over side A of 12. And so now going back to what you did last lesson, we cross multiply, we take the inverse sine, and we end up with an angle A that is approximately 48.3 degrees. So now we can put that in for angle A, 48.3. And then finally, for angle C, that's pretty easy because if we already have two angles, angle A and angle B, then we know angle C is simply 180 minus the other two angles, and that gets us an angle C of about 93.7 degrees. And there we have our solved triangle. All of our pieces, all three angles, all three sides have been discovered. All right, let's take a look at one more case, which is the SSS case. So this is a case where we know all of the sides of the triangle, but we don't know any of the angles. So we're being told that side A is 8 feet, side B is 18 feet, and side C is 13 feet. Again, we don't have a picture, so let's just start by drawing a quick sketch. We'll make this angle A, angle B, and angle C. And so that makes this side A, which will be 8. That makes this side B, which will be 18, and side C, which will be 13. Okay, and in our table, we'll go ahead and fill in H for A, 18 for B, and 13 for C. So now we need to find an angle. And it doesn't really matter which one we choose at this point. They're all going to be kind of equally the same amount of work. So I'm just arbitrarily going to pick angle A. Okay, so in order to find angle A, I'm going to set up the law of cosines again, which in this case means A is what I want out in front, and then that would be b squared plus c squared minus 2bc cosine of angle A. So in this particular version of the formula, the law of cosines, the part I don't know is angle A. So I'm going to fill in everything else. I'm going to have 8 squared being equal to 18 squared plus 13 squared minus 2 times 18 times 13 times the cosine of A. Now when we go to solve this, your first step is going to be to take your 8 square and subtract the 18 square and the 13 squared. But that's it. Only go that far in your first step. And that's going to give you a negative 429. Then you're going to evaluate what the 2 times 18 times 13 is and keep that out in front of cosine A. And that's going to be a negative 468 cosine A. Now, in order to isolate cosine A, we actually need to divide both sides by the negative 468. So we're going to divide this side by negative 468, okay? Because it's being multiplied to the cosine. It's not being added or subtracted to it. It's being multiplied to the cosine of A, so we have to divide it to move it over, okay? And that gives us about 0.917. So the cosine of angle A is supposed to give us 0.917, which means if I take the inverse cosine of that 0.917, I will end up with angle A, which is about 23.6 degrees. Okay, so we can now put that in, 23.6 degrees. All right, so now that I have an angle, I now also have a ratio that I can set up. So now I can go to the law of sines and take the sine of the 23.6 over 8, and that would have to be equal to the sine of, let's say, angle B over side B, which would be 18. And so when we work that all out, we can end up with angle B being approximately equal to 64.3. So that's my angle B here. And then finally for angle C, again we're just going to subtract the other two angles from 180 and we get about 92.1 degrees for angle C. And there we have our solved triangle. So it's really all about using the law of cosines to either find an angle that you're missing when you have all of the other sides, or to find a side that you're missing if you have two sides and the included angle. Those are the best situations for the law of cosines. And then the real beauty is using that in combination with the law of sines to be able to solve your entire triangle. All right, now, originally this was meant to be the online version, and then in class we would talk about a couple more problems. But if you would go ahead and turn over your notes page, I want to just talk about the one more problem since I won't actually be there to go through this with you. So skip the softball problem that's at the top of that page, but go down to the area problem. So we saw in the last lesson that sometimes we need to find the area of a triangle when we don't know what the height of the triangle is. We know other things about the triangle, but we don't really know how to find the height of the triangle. So we saw one option for finding area in that case, depending on the information we knew. Well, today we're going to see another option for that. And this is an option that works if we know what all the sides of the triangle are. So if we know the length of each side of the triangle, but we don't necessarily know the height of the triangle, we can use what's called Heron's area formula to find the area of the triangle. And the formula says this: in order to find the area, we need to take S times S minus side A times S minus side B times S minus side C, and then take the square root of that whole thing. And the S comes from taking 1/2 times the sum of the sides, or something called the semi-perimeter. So half of the perimeter is where we get S. And then to find area, we take S times the difference of S with side A, times the difference of S with side B, times the difference of S with side C. Take the square root of that whole thing, we get the area of a triangle. So let's just work through that real quick as an example. Here we have a triangle that has sides 22, 40, and 50. So the first thing you would need to do is find S. So S is going to be 1/2 times all of my sides added up. So the 22 plus the 40 plus the 50. And that ends up giving me a 56. Okay, so now to find the area, we're going to take the square root of that 56 times 56 minus side A, which was 22, times 56 minus side B, which was 40, and then times 56 minus side C, which was 50. Okay, so that means taking the square root of 56 times 34 times 16 times 6, or the square root of 182,784. So when I take the square root of that, I'm going to end up with an area of about 427.5, and since we don't have any units on this, it's just going to be square units. So it's a nice, sleek little formula to use when you know what the lengths of all of your sides are, but you don't necessarily know any height to your triangle, so you can't find your area in the more conventional 1/2 BH kind of way. Okay, so if you can use this formula, it's a nice way to get area in this particular situation. And you'll have a couple of problems in your homework where you're asked to do that. All right, so that should get you through the information you need for your homework. I'm sorry I can't be there to help you guys, but I know Miss Wong or whoever else might be your sub will be real helpful. So make sure you ask them questions, ask each other questions, help each other out. Hopefully I'll be back on Monday and we'll get back on track then. Until then, take care. We'll see you later.